So in this video, I want to introduce your next take-home assessment, Evil Hangman. So in class, we interacted with this program. We saw that a game of Hangman is one where the one player chooses a word and the other player is guessing letters to try to guess at what word the first player thought of. The first player in our context will be a computer, and so it chooses some word, and as you're guessing, it's telling you if you're right or wrong and showing you which positions the letters that you guessed appeared if you were correct. Now, we saw in class that, or mentioned briefly, that this game is a bit evil in that it's not going to choose a word honestly, it's going to consider a set of words, and it's always going to put the letters that you guess in such a way that maximizes the number of words possible each time. So what I want to do in this video is partially walk through that algorithm, even though it is explained in the spec. So here I have a little PowerPoint slide version of this. So consider we're playing the game of Hangman with a dictionary of words: ally, beta, cool, deal, else, flu, good, hope, ebex. These are the only words in the dictionary that the computer could consider. And so it starts by considering all of them. And so since we're going to be considering words of length 4 here, it starts off at the beginning of the game with a pattern of just 4 dashes. We use a dash as a placeholder for a character that has not yet been guessed. So far no characters have been confirmed as being correct, and so they're all dashes. Okay, so then the user guesses E. And what we're going to do is we're going to go through and try to make every possible pattern for each word in this dictionary. Now note, the best way to implement this is to go word by word and make the appropriate pattern for it. So for example, what I mean by that is start with the word ally. Where does E appear in ally? It doesn't appear anywhere. So the pattern, using the current pattern and the guess E for the word ally, results in the pattern with just dashes. There's no E's in there, so there's nothing to update. Okay, next word is beta. What should we do with beta? Well, there's an E in the second position. And so the pattern, if beta was the word, it would be dash E dash dash, beta. So now going on to the next word, cool, there are no E's. So we'll add that on to the pattern with all dashes. Deal has an E in the second letter. Else has a different pattern of E's. Flu has it in the third position. Good has no E's. Hope has it in the fourth position. And ebex has it in the third. Again, I'm not generating every possible place an E could be. I'm going to each word and saying, hey, if you were the word, what would the appropriate pattern be here with the guess E? Now that we've kind of broken them up into these word families based off this pattern, where you might want to represent it as some sort of mapping from pattern to the words that belong to that family, now the job of the computer is to pick the largest set of words. So since ally, cool, and good has 3 words in it, which is larger than any of the other pattern sets of words, we'll choose the pattern dash 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 dash. So we'll just we'll tell the user that they were wrong, that there was no E in the word, and then just limit ourselves to these 3 words. Okay, so now the user might guess again. Say they guess the letter O. Well, we just do the same process again. We go through each word in the dictionary. Right now it's just ally, cool, good. And we make patterns based off whether or not an O would be present. So ally would end up with no O's, so it's just the pattern dash 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 dash. While cool and good both follow the pattern dash O dash. And so since cool and good has the larger set of words, we'll tell the user that the pattern has dash O dash. Okay, so now the user can keep playing. The set of words we're considering is just cool and good. So then the user might guess D, and the same process. We generate the pattern for cool using the letter D and good using the letter D. One thing to note is that the patterns we're generating are always based off the current pattern. So the 2 possible patterns would be dash O dash, no D included, and dash OOD, with the D included for good. And now we always have to choose the largest one. Now in this case, there's a tie. Both of these patterns have 1 word associated with them. And so our specification says, hey, you should always choose the pattern that comes alphabetically first. So when you're using some kind of structure that you will be using to represent these patterns, you probably want one that sorts the patterns based off this alphabetical notion. And as an implementation note, dashes come before letters in alphabetical order, according to Java. And so we pick the pattern dash OO dash because that pattern comes before dash OOD. Dash comes before D. And so we pick the dash OO dash pattern. That was a picture of a dog I drew from a different quarter. But yeah, so that's how this game is played. So a couple things to note about resources and things that you might want to look at. So the specification walks through all of this. In fact, at the very end, there's the exact same walkthrough of a similar game that I just had in the slides. But the specification walks through all of these things. So I want to mention, kind of like Assassin Manager, there's going to be one method that's going to be the most difficult one, and that's going to be the record method. The record method is actually recording a guess and doing all this logic of breaking things up into patterns and choosing the largest one. So like with Assassin Manager, I recommend you save record till the end. Focus on getting everything else set up correctly. Maybe write your little test program to make sure, guesses left and pattern and all these things are working as expected. And then start iteratively develop record so that you can start building it up piece by piece. Okay. So record will be the most difficult one in this assignment. So make sure you're spending lots of time on that. So we walk through some implementation guidelines for all of these things. Okay. So the specification will have lots of really good information about implementation guidelines and tips, and also how to run some important points about running the program. In terms of, let me go back to the main page. So in terms of the output comparison tool for this assignment, one of the things that you will note is that your Evil Hangman program has some class constants in it. So the specification walks you through this, that there are two constants in the Hangman main that you can change, so to change the dictionary or change if it should show counts or not. And so the different output comparison tool cases tell you which dictionary you should be using. We provide two dictionaries, one large one and one small one, and so the small one might be easier, more available to debug. Okay. And so yes, the spec has lots of information about all the tips for this assignment, as well as our normal things about code quality, commenting, and a JGrass debugger. Again, do please check out the frequently asked questions at the bottom of the homework page.